Hi, my name is Devat, and I'm a part of one cohort which is AI Sprint from Ayush Singh. And yeah, I took machine learning course of famous Dr. Andrew Ng, and I have completed that machine learning course as well, where I've learned about all the supervised and unsupervised algorithms. But what I found something interesting with this cohort or this lectures, since it's just a first week of learning supervised and unsupervised learning. I found something interesting. So I want to talk about these 4 steps. Let's start with this. First section is I was assumed that machine learning algorithms are about deriving mathematical equation that someone have already derived, and we are just passing to the data and trained our machine learning model with good accuracy score, and I call my model as a good model. I used Kaggle dataset. I have made data engineering pipeline and deployed those kind of models without monitoring, just with accuracy scores. And I was just assumed that my model was great. I don't I was not thinking about data drifting. I was not thinking about model monitoring. I was not thinking about data leakage problem. But yeah, so I will talk all these things in this video. So first start with my assumptions early on machine learning algorithms. So my first assumption was that good model is about good accuracy. 90% accuracy. If I achieve 90% accuracy, I compliment myself and say, yes, I achieve a very good model. But it breaks a very important thing, that why I am even training machine learning models for business, right? And if my machine learning model is not giving any business value, then my accuracy is just a useless thing, right? No matter how good accurate my model is. So another thing is which algorithm is best. First, I have gone through each and every algorithms, and I compare those algorithms internally and try to find which algorithm is best. Then that assumption also break, that there is no something called a best algorithm, but which algorithm fits my problem or a business problem and can solve business problem very comfortably, very precisely. Will it help generating more revenue, or it is not giving any business value? If it is helping generating more profit, then even linear regression or logistic regression like simple algorithms are best. Okay, so there is one example. In Let's take one example of logistics domain. uh, Shipments. Now some there is no one is asking about ship how much I'm sorry, shipments are delayed by which time, like 1 hour, 2 hour, or if there is a far if there is a long delivery, then it will be a 24 hour, 48 hours. Likewise, no one is here. If I take this problem as a regression problem and predicting the exact time, which which gives nothing to the business. What will I do after I get that this shipment will delay 24 hours? What what is the decision I'm making after this prediction? It's not making any sense. Rather, I ask, will this shipment be a problem or not? Problem means delay or not. Then I start thinking about the evidence that and what are the features. Is vendors is at good ratings, is weather condition is all right, is route is all right, is it festival season or not. If all this tick marks is positive, then I can flag that this shipment is on the flag category. Put it as a red flag. Yeah. And one more thing. Recall, I was totally run behind accuracy. I was not focusing on recall and precision. The real business revenue loss at the recall side, not at the accuracy side. Recalls is a false negative. I don't care about false negatives. Then my business will hit hard on revenue. It will lose on revenue. So these are the assumptions, and these are the thinking mindset, my thinking thought process I'm shifting, that how to think about the problem. Another thing is very universal. This thing is hypothesis, loss, and optimization. Every algorithm follows these steps only. First, hypothesis, which is mathematical shape, then loss, how far the predictions are from the actual values, and then try to optimize it. Let's talk about it in the next section. Let's do this. Sorry, gradient descent. Let's say that I assume that every optimization is done via gradient descent only. Gradient descent is the best universal optimization solution, but it is not. When I learn the decision tree, and yeah, one more thing, I have just go deep into one algorithm, which is linear regression, and I just compare linear regression with all the other models. First, logistic regression, then decision tree, then XGBoost, and then support vector machines, right? So after figuring out with all this model, after figuring out and going deep into all this four model and compare with it linear regression, I found very common thing. First common thing is this, that every algorithm is follows this phenomena. Hypothesis, model have some mathematical shape, then loss, then optimization. And yeah, and I was always thinking that optimization means gradient descent. We have to draw, there are loss function will give some curve and make differentiation and try to adjust weight. I will get optimized version of the model. But I was wrong. But I was wrong, because gradient descent is not even used in some algorithms like decision tree. No gradient descent phenomena. Support vector machine, no gradient descent. I was surprised how this thing is happening, because decision tree and decision tree is solving some problem at tree or architectural level with if else condition, based on historical if else condition. It is also classification problem. Logistic regression also solving classification problem, which is binary classification, which is also something based on if else, but different from decision tree. Decision tree is not making any probability at each and every step. It is just splitting the data points, a pure data point, as one node, and remaining at particular condition on one node, same particular data point, and another node at a different condition, similar kind of data point. And the depth of the tree will decide the optimization. And decision tree uses generally greedy optimization problem, which I don't want to go technical into this video. Yeah. So yeah, the thing break my thinking is gradient descent is universal problem. No, it is not universal optimization problem. There are different optimizations available for different algorithms. Yeah, and the last thing and the most important thing, which is I found my way to get out from the tutorial hell after completing Andrew Wang's course, which is really great. I have no doubt about it, right? But the TED course is not telling you anything about business decision. It is only pure mathematical and how to train model, those that kind of course. But the if you can't apply model machine learning to the business value to get the more revenue of the business, finally after all, business should get revenue, right? So I realized that problem for framing, yes, problem framing is a great skill, right questions to ask, because right now I don't even need to write a code. AI will write code for me, but what to solve is more important thing. Model, if I form if I frame the wrong problem, model will give the right prediction, which is ultimately a wrong decision, right? Model is not giving the wrong decision, model is giving the right decision. But the as my problem was wrong, right, as my problem was wrong, model calculation is right, overall decision making process will fail, model will fail. Right problem, how to ask real questions. First of all, let's take one example I like is, will customer churn or not, right? Instead of finding yes or no answer, we can divide that into three pieces. We can divide that problem into three pieces. First, what business want, whether to, rather than spending or wasting time on those customers who will churn, not even churn, sorry, I'm sorry, whether to waste time on the customer who are less uh, important. I can first calculate the revenue based on each and every customer. Then I'll find the classification that customer will churn or not. Then I rank those customers, and marketing team will focus on those potential customers to get conversion. This is how I can uh, make my recall very high to reduce false negative. So very high recall means uh, the revenue loss is also less. If I make a recall very low, that out of 100 customer churning, if I model suggest only 12, only 20 customer catch as a churner, then my revenue loss is very high. If out of 100 churners, if I model can capture 80 people, then those ratio and those recall, that recall is good uh, metric for revenue generation. Yeah. So yeah, this type of thinking and this type of thinking frameworks help me get out from the tutorial hell. So yeah, I can tell someone who watch YouTube videos or tutorials after tutorials or getting into one course after another, pick one more problem, try to ask the right question, what business want, how revenue is affecting, how machine learning model help to increase the revenue, and yeah, optimization is not a technical thinking, it's more of the business problem. Yes, the optimization is not about finding the good weight and bias value. It is about finding real business value. Yeah. So that's it. This is the thinking about the first week. And yeah, I'll see you in the next video. Bye.